Boston Dynamics just dropped a new video of its humanoid robot Atlas. Instead of just dancing and jumping, now the bot can do what looks like useful work. This comes on the heels of their announcement a few weeks ago of a massive partnership with Nvidia, who's going to provide the chips, the compute power, training, and the AI brains. Today we have a humanoid bot expert who will not only review what Atlas can and cannot do, but also explain to us what exactly is useful work. The reason this is important is once robots can do useful work, that is the point when mass production is going to happen. We have Dr. Scott Walter joining us. He is a two-time robotics co-founder. Thank you so much, Scott.
Hello, Herbert. Glad to be back.
This is big news from Boston Dynamics. People have been waiting for this. We're going to watch quickly the video that they dropped just a few days ago. This is their announcement, right? You can't trip Atlas up. We already know that Atlas can do a bunch of dancing and jumping, and we're going to play that video. But now their humanoid robot can get ready for real work, combining strength, perception, and mobility. I'm going to go ahead and play this and go ahead and talk to us as we're watching it.
Yeah, so this is a video I guess we've all been expecting Boston Dynamics to show us something, since they've been maybe kind of quiet of recent showing us any sort of progress with Atlas. And so we're now seeing that they have made some changes. And one of the first major changes is that Atlas now has hands. Did not have hands before, and is able to grab what looks to be like a real world object that you would see on a manufacturing floor. Now, a lot of questions in here, such as like, where is this located? What kind of parts and components are these? Who is it for? And what exactly are we seeing in there? So we're going to break this down sort of frame by frame to give everyone an idea of what is happening, how Boston Dynamics is solving this particular problem, and what the potential could be in the future for them. So the first thing is you can see is that yes, Atlas does have hands. And when you look at those hands, what do you think?
Well, I know that in the past we did hear Robert Plater, the CEO of, let me show you quickly what he looks like, the CEO of Boston Dynamics, right?
Yes.
He did say that, in his mind, it needs to be useful work as in a factory. He wants really strong hands. In fact, he doesn't even have to have all the 5 digits. That's why they're heading in this direction.
Right. And so the original Boston Dynamics hands, there wasn't really anything, or I think that has something pretty simple, but we see there's now fingers, but there's only 3 fingers. Mm-hmm. And that's usually a lively debate when you're coming up with a robotic hand. Does it need to have 5 fingers like a human? Yes or no? And all the other humanoid bot companies have pretty much answered that with a yes, it does. Okay. But in this case, a minimum of 3 is probably what you could get away with for being able to do most grasping kind of applications. Now, there are 3-fingered grippers out there that are on standard industrial robots. This is kind of a unique design because it kind of is aligned the way a hand is, that all the fingers are together. But in order for a hand to work, remember, you need an opposing thumb. So just having the fingers themselves are not going to work. So a little trick they have is like any one of those fingers can act like the opposing thumb. And the reason is because their knuckles are double jointed. Mm-hmm. Now, they don't have 3 knuckles like a human hand. So you can see right there, when it opened up, you can see how the different knuckles opened up in a different direction to give you an idea of that. So they're probably able to move, I don't know, plus or minus 120 degrees from the straight out position in order to grasp any particular object. And they look very strong. And it looks very much like an engineering solution. Okay. It is really not something that is designed to be a full humanoid bot. Again, you're not going to be playing the piano with these fingers. You are going to be using it to grasp objects, and certain kinds of objects that tend to be more in a factory environment. I don't think you're going to be folding t-shirts with it or anything else. So they've kind of limited it in scope and to come up with what I'd say is a very nice engineering solution to a particular problem, but not necessarily that's generalizable to the whole humanoid bot space. So that's the first step that's going on there. It's a little bit unique. I think it's going to be questionable how easy it is to teach these tasks telerobotically, because their hand is able to do things that a human hand cannot. We do not have double jointed human hands. So it'll be kind of challenging for a teleoperator to learn exactly how to do that. Not that it can't be done, but it means it's not a one-to-one mapping. So there's like a learning curve that has to go on there. The other thing you'll notice is that they pointed out how this is being done. And so we can assume from what they've talked about how it's being done, we know a little bit about how it's not being done. They've talked about, showing off the strength the perception, and the mobility. Okay, we know Atlas is very mobile. It's probably one of the faster humanoid robots out there, and we know it can do backflips and everything else. That's the first thing. We know it's very strong. So in this case, it's lifting an object. It seems to be a strut for an automobile or like a light duty truck. And it probably, the guesstimates are around 30 pounds. I just grokked it, asked Grok how much it is, and it could be anywhere from 20 to 30 pounds. So it's a guesstimate. That's a fairly heavy kind of object, let's say, compared to what the other humanoid bots are considering being able to lift. So Optimus, I think, is looking to be around like 10-pound deadlift, but we know it was able to pick up another Optimus arm, which is the order of 15 pounds. So it seems to be a little bit stronger or brawnier than, let's say, the other humanoid bots and the kind of tasks it's thinking of going in and doing. And then there's the other thing. So we see it's got strength. We know it can move around, but then perception. What does perception mean to you? Does that mean end to end do you think, or does it mean something else?
I'm not sure what you meant by end to end, because perception to me is simply vision, maybe hearing, maybe sound, but being able to understand what's going on.
If they were doing end to end, they would have said end to end. Instead, they said perception, which means they have a camera system that can identify objects in the world. Well, their camera systems have been able to do that for quite a while. So they are using, a form of AI, the AI that has been in these perception systems for a while. So there's nothing groundbreaking there. And when you look at what they're doing, they clearly have a virtual world already where they've described a few objects, such as the thing we want you to pick up. And so they've already got CAD data of that. I do not believe that is something that is coming from like a LiDAR that is scanning it and is being created real time. I believe it was like already there offline, something they imported in. And they also have like a model of the bot that is being overlaid. So you're taking what is happening in the real world and then in the virtual world, and you're overlaying the two to see what your error is between the two. And we can actually see in a couple of the images that there is a lot of error. And that actually surprised me a little bit. I was expecting, there's going to be error between the object because you're never quite sure where you grab the object. You might have a really good definition of the object, but you're not grabbing in the right place. However, you should know where your hand is. And you'll notice there's a big mismatch between where the hand is in space and where the virtual world thinks it is. So it tells me their proprioception is it's either a little bit off or their camera system is not quite calibrated right. And the one example that I think is a really good camera system is the Apple Vision Pro. Yeah. You put that thing on, and it's as if you are really seeing the world through glass, as opposed to you actually looking at cameras. Now, it could be miscalibrated in that you think you're looking at something straight ahead, and it's like that. And the way you would tell is you put your hand in front of the glass like this, and you take it off. And if your hand is in the same place when you do it, and it's like, wow, they really calibrated that on there really well. And to do that is a very tricky thing. It requires a lot of calibration and math to be able to align that thing. So it could just be a simple mismatch like that, or it could be it's showing a lot of the loss function, or they're not quite sure where they are in there. So when I saw that, I was surprised that there was that little bit of mismatch. The other thing, what do you think of the noise? All the sound that you're hearing there.
Mm-hmm. Yeah, that's it sounds like it's pneumatic instead of it being.
It's hydraulic. It's hydraulic. Yep. And there are a couple things that kind of stuck out at me. First of all, what is it doing? You have any idea what it is doing?
What do you mean? What is it doing?
Well, it's taking a part out of like one container and putting it into another container.
Mm-hmm.
and
first of all, Scott, it looks like that they sped this up, right? If you look at the curtain movement and these guys here, it looks like this has been sped up.
It's hard to tell. I don't know. I haven't seen it that way. I mean, it does seem that there is a lot of moving around and pausing while the perception system is trying to understand what it's doing. So it is very jerky, and it's not a series of smoothly connected motions. It's like, do this, now do this, now do the next thing. So it takes a while to move there. And of course, you can hear it moving through there, and you'll begin to see kind of the mismatch. Like, I think right around there, I end up seeing there, stop, is that you can see how the hand and the overlay missed. They're not there. The other thing is look at that rectangle down there with what should be like a white piece of paper or some information. That is blurred out right there. Yeah. So you see when the hand goes through it, you can't see the hand because it's all blurry. Yeah. They don't want you to read whatever is there. So there's some important piece of information on there, which is probably identifying who the customer
I
is.
know what it is.
Yeah.
It's the QR code. As we've been
Maybe.
saying before, many times before, whenever you see the Boston Dynamic videos, you got to look for QR codes because this is all hard coded. There's no intelligence here.
Okay, that could be
If I see the
a good
QR
reason.
code,
Yeah.
I now do something. Yeah.
Now, the operation kind of struck me as a really odd operation. And I think connecting the dots sort of connected the same dots I did. I was like, well, this is curious, just moving it from one container to another. How was that helpful in the factory floor? Why would you set up an operation like this? Is it just to make it easier for the operators on the other side of that preloader to be able to grab the parts and move them into the position that they want, as opposed to grabbing them straight out of there? So it's either like seems really inefficient, or this is just something that kind of made up for the sake of showing some kind of operations of manipulating something on the shop floor. And then the other thing is that we can't exactly see what that is. Are they trying to blank out the QR code? The other thing is we know exactly where this is. And we know exactly where this is because we've seen the same environment before. And so thanks to Brian White, it kind of reminded me that, oh yeah, this is the exact same laboratory that they've been doing everything else, from the dancing robots that we saw with Spot and other images. So it's not on site anywhere. And they've just brought in what looks to be something from a potential client or potentially the owner. So let's remember that the company that owns Boston Dynamics is Hyundai. So it could be that they are cooperating with Hyundai now to see, are there some operations that could potentially be done in some of their production environments. And then the other thing to remember is, how long is a shift, Herbert? Do you remember how long people typically work on the shop floor?
I don't know, 8 hours.
Something like 8 hours. And what's the runtime of Atlas at
Of
this
these
point?
bots, maybe 2 hours if they're lucky.
Yeah. I think they said like an hour and a half or something like that typically. And it's hard to say if you're lifting what appear to be 30-pound objects a lot. It may be that you're lucky to get that hour to 2 hour or whatever. So it's going to be challenging for them to be able to do the entire 2 hour or 8 hour day without some other provisions to be able to make it go ahead there. Now, there's some very interesting things about the motion that I want to take a look at, especially when it walks around to pick everything up. So,
let's take a look at that. So after the beginning.
Yep. So we got that. We're kind of, putting it on in there. And as it starts to move back to grab the next one, it takes a pathway because it's got to get around that corner post that's there. So we're going to see that just in a second after it's done. And it's not clear whether it almost gets tripped up and is able to recover itself. So we'll see this task again. You'll see that they don't quite perfectly align, but they're close. They're a bit close. And now there, it's not clear what that was. Now, did the robot suddenly lose its balance a little bit? And that really weird hand motion there, was that something to recover? Or was that almost like Atlas saying, yeah, I just nailed that? It's just like a baseball player who gets a base hit, just like, it almost looked very emotional at that point, but it may have just caught its knee on there. And I was looking at that because I didn't quite see the knee, but you notice how the hand just kind of made it over? It was very curious because look at that. It's like almost hit it, just missed that. I was thinking, do they have a really good occupancy network in there where they really know where everything is? And it just pulled the hand out of the way in the nick of time. Normally we would give wide berth going around, especially if it's a machine. A human, we kind of know how to cut that corner and get away with it. But we know we have to pick our hand up there because we probably busted our knuckle on it once before. And we remember, oh yeah, when you go around there, lift it up. And also when it picks up the part and comes back, it comes really close to hitting that post and somehow manages to avoid it. So I'm wondering, say, wow, have they done a really good job here on the occupancy network to make sure it doesn't hit those things because it's really cutting it close? Or was it just extremely lucky all those times? And these are just the ones that, that there should have hit. And if it is hitting, then it's like, whoa, wait a minute. That's not what it should be. You need to do a better job. And it would seem that to me, it looks like they're just getting away with it more than anything else. Now, the other flashing that you see there, that is not like a scanning system or anything like that. I think that is just letting everyone know that the bot is operational right now and to stand clear. So that's more of a warning. So that was a rather interesting route that they took. You think they would have planned that a little bit better?
The other thing I noticed is that, this, look at this, right? It
Yes.
looks exactly the same, except for the
Hmm.
hands. They just screwed in
They
new
changed the
hands,
hands,
but
right? Right.
it doesn't
Hmm.
seem like they've slimmed it down anymore. Look how big the backpack still. It still has that giant wire cable
Hmm.
wrapper still dry hanging out like that loose. It's still the same bulky size it's always been.
Do you remember the Kodak Advantix?
No, was
Okay.
that a camera? Yeah.
Well, it was a type of film that Kodak came up with
Mm-hmm.
when it was clear that digital film was going to win the day. Kodak was
Mm-hmm.
a film company, right?
Mm-hmm.
And so everything was chemical film. And then suddenly things started to become more digital. And they decided to come up with kind of a cross or a hybrid between the two. It's like, well, wait a minute, we make film. And they came up with the Advantix because it was going to have these things in there that would make it a little bit easier for digital scanning. It wasn't quite clear what it was, but somehow it was advanced. And it was like the last gasps of
Mm-hmm.
pretty much chemical film. They were trying to take an old platform and squeeze as much as they could out of it to stay relevant at that time. That's a bit of the feeling I have with Atlas. Atlas was great in its day when it came up and it was able to be a good development platform, kind of spur the industry on to do a lot of these things. They made some decisions about we're going to go hydraulics. Everyone else has decided to go with electrical actuators for a couple of reasons. One is the power consumption is a lot better. I think also the fidelity is that yeah, you can get a lot of strength and power out of hydraulics, but you're brutish. If you need to be a bit more delicate, you get much finer control from being able to have electrical servos, electrically activated actuators. So uh, they're using like these technologies that are just not quite the right one, and they're deciding to stay with it. And I think what they need to do if they want to get into the humanoid bot space is they just need to do a clean sheet. They've learned a lot. They know a lot about control systems, but I think it's really time to retire the platform and
Mm-hmm.
start moving on to something else. And then they will probably be able to do a lot more. So again,
Okay,
like
what?
the hands, it's not a
Mm-hmm.
humanoid hand. It's like we've got to put some sort of manipulator on there to be able to grasp these things. And so they turn to the tried and true methods that we've been doing for 40 years with industrial robots. And I'm sorry, it's like that's like the wrong hand design. You need to start looking at the human hand design and remember it can do a lot of things. It can do delicate operations. It can do very complex. So if you want to be general purpose, you need a humanoid hand. If you're just looking
Yeah.
at very narrow applications in a factory setting, okay, that might be fine.
And I know that you and I have talked to a number of robot companies now, and they are basically saying that one of the best ways to train a humanoid to be able to do something autonomous, like letting them be discovering their environment, doing something, is teleoperation. Once you do teleoperation, where a human actually helps them do a certain task many, many, many times, then that bot will know what to do, even if it's slightly off and so forth. And what you were saying is that teleoperation works best if the humanoid is very similar to the human, even
Hmm.
to the point of like if I'm going to pour water from one glass to another, I want to teach the robot to do that. Sometimes my head might just look at the bottle to the left, then my head moves to the right, and I do that. But if I don't have actuators on my neck, you were pointing out, then it becomes there's just that one little thing that the robot needs to figure out that why is the human doing it, but I'm not doing it.
Exactly. I
Then
can't
they
do it. I
have to
don't have
figure it
that
out.
capability.
And so
Mhm.
if they have these three finger prongs, but the human is using five, then it becomes much harder for for the robot to figure out what to do. So that's what you're saying. But a couple of weeks ago, about 3 weeks ago at the CES conference, there's a big giant announcement that Nvidia is going to power and partner with Boston Dynamics. So I'm going to go ahead and play the Nvidia Isaac platform. Nvidia's Isaac is this AI platform that they partner with not only Boston Dynamics, but 12 plus different robots. And I'll show you this and I'll play it and you can explain to us what we're watching. So my question is, could this AI that's coming from Nvidia then teach it, the Boston Dynamics, the intelligence that it needs to have?
Yeah. What my feeling is that what the NVIDIA system is like I say, that it's an ecosystem with a toolkit to provide a lot of the capabilities that these researchers need to be able to develop what it is their end goals. And
So
they talked about a lot of different robot companies out there, and
Mhm,
not just humanoid robot companies, but also companies that are making automated, vacuum cleaners as
mhm,
well as lawn care. So, it's looking for a very broad kind of spectrum, not just humanoid, But a lot of the training data you need is that you need access, of course, to the training compute that you're going to have to be able to train everything up for the neural networks you're going to have, as well as the physics for the simulation. And Nvidia has got some very good physics chips. So you're going to have to still develop your own model, but once you have the model, you have something that will allow you to simulate it very quickly and very accurately. I can sit down and write my own little code to simulate something that's physics, just applying, F equals ma. And at some point, if things get really, really complicated, my CPU just cannot compute fast enough. So what you have is you've got these special boards like the GPUs that Nvidia has, and a physics engine which takes care of a lot of that for you. So you don't have to worry about the deep down stuff. You just start building on top of it to be able to solve the problems that you need to solve. So what they're doing is they're providing a suite of tools that's going to make it easier for these researchers to build it. I don't think they're necessarily going to be developing the AI for these companies, but giving them the tools to allow them to develop the AI.
Okay, let's take a look at the tools. This little clip here is a minute and a half long, comes from Nvidia, and it shows you the kind of capabilities. So in this one, it looks like that a human can type in tasks or rules, whatever.
Yes,
actions.
So there'll be like a built-in LLM where there's some examples in there are showing how some of the bot companies are adding LLMs to their interface. Like Agility in this case now has the ability to ask the robot to do a particular task just with natural language, and also using cultural references and everything else. So it's very different than the traditional way of training. And that's a heavy lift for a small company that has never developed all these tools. So it's nice to have something like that you can begin to integrate into these platforms so you can focus on what is your specialty and not worry about some of these other things that are let's say, being developed around you, because there is a huge ecosystem of different AI kind of tools that would be nice to be able to pull together. So Boston Dynamics is one of those companies that's also utilizing that. And as we can see, there's a whole host of bot manufacturers we haven't even seen before. So many of them researchers, and of course, that's not a humanoid bot. But in order for these Roomba-like vacuum cleaners to do well, it doesn't hurt to have pretty good AI. And the same thing, obviously, with a lawnmower. It's not a bot, but it's a pretty dangerous thing. If it's running around, not understanding its environment, it could cause a lot of damage. So you want to make sure you have a lot of intelligence in there. And of course, Sanctuary as well is using that. And I suspect they're using it also because it's a really good foundation for them to be able to build on, because they need to simulate. They need to have a really good model of their bot to understand what it's doing. And so it makes sense to team up with Nvidia, because not only do they have the good hardware that solves all of these problems, but it looks like they've also built a pretty good software suite around there, what they call Isaac, to make it a lot easier for researchers to be able to get in there and start working with it.
Okay. I'm going to go ahead and just explain what I understand it to be so that people can understand what this is. This is Isaac, which is coming from NVIDIA's what they call robotics ecosystem, and they're partnering with a bunch of robot companies. In this case, it's instructions given through text, and it says, go grab this thing and bring it back here. And so, the bot then acts and does it. So it's pretty straightforward. You just give it a text. In this case, they're saying, hey, robot, go pick up the box that is the same color as Darth Vader's lightsaber and put it to the tallest column. And so then the bot, that's all. If you use that language, it knows that Darth Vader's lightsaber is red. It knows to grab the red box, and then it searches for the tallest, which is number 4. That's what it's doing here.
Right. And notice one other thing they have there. So you have the LLM, you have the simulation environment, the graphics, which is NVIDIA is known for. But you have to go beyond just, the graphical simulation of the animation. It's based on physics. So that's the other thing that's kind of going on. So they're providing that background to allow them to teach the LLMs and build these things up make sure their language model is working in a simulated environment. And then when they're all done, you see they were able to deploy it in the real world. So that means these bot companies do not have to develop all these tools on their own. They now have access to them.
In this case, you can give it different instructions, and then once it, shake hands. So now it knows what shake hands is. Now you can use verbal or you can use written, and now it'll do that action that you trained it on. This is lie down. This is nod your head.
Welcome to Boston Dynamics.
Now this one is verbal. So now they give you the ability to talk, and then it gives the robot the ability to talk to you. So you can listen to this words.
And I will be your guide for today.
Hey Spot, how do you like your job? Ah, Mr. Matt, my employment as a tour guide provides great satisfaction. Now behold the rock pile.
健康的なランチのテーブルを準備してください。
You can also do different languages, Japanese. And
Yes.
then now they're saying that this can apply to different robots,
Different
even
form factors.
not just humanoids. Yeah.
Mhm.
Okay. So you're saying, yeah, that's just the tools. Boston Dynamics still needs to do a lot of work. The video we watched, it doesn't seem like, it still feels like it's all coded, but it's now at least no longer just dancing, which we showed a video of that. It's now actually doing useful work. So why don't you tell me about useful work? This is a great tweet that you did where you explained useful work. So you say that when will bots finally do useful work? Sooner than you think. Let's define it. So your definition, a bot has done useful work when it can perform a task currently performed by a human at the same efficiency, reliability, quality, and endurance at or below cost parity with the human wage. So each one of these has to be hit, has to be efficient, reliable, has good quality and endurance at lower cost. The task does not matter so long as it's any task currently required in the factory or business. The outcome must be quality and reliability. It has to have reliability to perform that task. Otherwise, it's why replace it with a human. Efficiency is important for cost parity, right? It has to be able to do it as fast as a human at the minimum. Endurance is extremely important. It must be able to perform over an entire shift without failures or glitches and show up the next day or shift without problem. Proving it can do a task reliably for 10 to 20 minutes does not cut it. An entire shift is required. It can use the same break schedule as humans if mid-shift charging is necessary, but that is all. It needs a durability and reliability to do repeated shifts without interventions. Shifts are marathons, not sprints. Cost parity is when the operational cost of the bot is at or below the human wage, including overhead. It will leave it to the accountants to determine the formula. It's that simple. Once it becomes cheaper to use the bot, it's dependable. That's your definition of useful work. I love it. Very complete. Scott, tell me more.
Okay. Well, the reason let's say I didn't coin the term useful work because it had been used by several other people. Elon, probably most famously, I think several quarters back when he was asked that question and when there's going to be in the factory. And he said, oh, I think next year, meaning this year, we'll start to see them do useful work. Brett Adcock also used it a couple of times in our interviews. I said, okay, people are saying useful work. We've got to really understand what they mean. And so having listened to them, the context of everything, I think that is a pretty good definition of what useful work is. So they've performed tasks, a lot of tasks that we already are able to see on the floor. The question, have they been able to meet all those metrics that it then becomes useful? So they probably could take Optimus and go in there and replace a lot of tasks on the shop floor right now, but it would be more of a gimmick at that point than actually affecting the margins, because it may be it can only do it reliably for an hour or two, or it's much slower than the humans, or the operational cost might be extremely high. It could be like $100 or $200 an hour, because it's not just the consumption of the electricity to keep the bot going, but you remember you've got like a whole field of engineers sitting behind there trying to keep it going. And if you need to have, let's say, 5 people right with the bot the whole time through, you are not saving money. You're proving you can do it. It's a good R&D project, but it's not useful yet. So when you get to the stage that the operational cost gets down, that's why it's going to be up to the accountants to figure out what the actual operational cost is of the bot. They can tell us what the operational cost is of the human based on the human wage and all the overhead over there. That's very clear. We just have to know when you get the cost parity. So if the bot can do the same task, but it's 3 times slower, well, okay, that's a problem. We got to get it up there to be the same speed. But if it can do it within the same tack, let's say it's a little bit slower than the human, but still it's doing it at the tack time that's required. Because remember, the human usually gets a couple second breather between every single operation. So they're only at about 80 to 85% operational load throughout a particular cycle. So the bot, so long as it just gets there in time every time and it can do it reliably and doesn't screw up and is able to make it through a whole shift. And then when the shift is over, assuming it then doesn't have to be completely torn apart and put back together again, which would be very expensive to do, that it can actually show up again and again because it has the durability. So it needs the endurance to make it through, and it needs the durability to continue going and going and going. And we don't know if they've met any of those yet. They've probably made a couple of those, but as soon as it does all those, and you get to the point that now it costs less than the human wage, you can say, all right, it's doing useful work at that point. It's not a simple demo. I'm sure they can go down and they could show to investors or anything else, look what the bot's over there. It's doing useful work. And it does it for 20 minutes. And then everyone leaves. And then whoop, the army of engineers come in there and they're going to drag it out and they do all kinds of surfacing work. And then we know that is not useful at that point. It really has to be able to do a solid shift. And then, like I say, then the next shift, the next day, and the day after that, and the day after that. It can have the weekend off, okay, to get repaired, I guess, like all of us do. But during those 5 days, nope, it better run without breaking down.
Yeah. So far, no humanoid bot has been shown that they can do useful work. Let's be clear. That's why I pointed out that when we watched Boston Dynamics, they clearly sped that up. You can clearly see that video was absolutely sped up. And so I'm going to just play that. I've been playing a bunch of other videos from Optimus as well, including Figure Robotics. And you can see this looks very sped up for me, as you watch this moving like that. And you watch these humans in the back. That's partly why they're just not even moving at all. They're told, don't move. It's not moving at normal speed here. So, okay. So that's step one, right? That's that. And you saw even Optimus is certainly not moving fast enough. It's still too slow.
Right.
And then, of course, I showed Figure Robotics as well. And they're still fairly slow at this point as well. So all of them are not quite yet ready.
Right. Now, in that same post, I said, when will robots do useful work? And then I said, sooner than you think. You might say, well, wait a minute. If you don't think they're that close, why do you think they're sooner than you think? Because the bot doesn't have to do every task in the factory. It just has to find that one task. And so there may be a couple out there that they're really close to being able to get because it's not something that's extremely difficult and something that's going to be extremely wearing on the bot. It might be something that's very easy that they can get the reliability down. There are a few other things is that it doesn't necessarily have to be as fast because it comes down to cost parity post out there where I was sort of talking about the bot multiplier. So it could be that the bot is half the speed of a human doing a particular operation or task. That task might require 2 operations. And those 2 operations have to be done within a particular time. And because the human is so fast, the human has been given these 2 or 3 operations to do within that cycle. But it could also be done by 2 humans, standing side by side. It's just that you have to pay both of them. And if they're doing 10 seconds of work and then 30 seconds of not doing work, you say, well, wait a minute, why are we doing that? Just have them go back and forth. So it may be possible that, okay, the bots aren't quite as fast as humans yet, but we get some operations over here where if that bot does task A, the other one does task B, and they're doing it within that cycle time, and our operational cost is like half that of a human, then we can say we're now based on that, we've sort of been able to hit, okay, it's useful work, because in aggregate, it's saving us money. And then the bots are doing useful work is when they are actually saving money at that point. And that's why I talk about cost parity. And so sometimes the accounting and the way that you will decide if it's useful or not may be a little bit nuanced, but I wanted to keep it simple. Despite the fact we've gone on trying to define this thing, the very simple thing is that when it is able to do the same task as a human for the same cost or less.
Yeah, so it's pretty inevitable, as we can all see, how fast this is progressing. Just a couple of years ago, they had to all have tethered, and then now you can see that you don't need that anymore. And now it's understanding its environment, right? You don't have to code everything; it can learn and understand it. They've proven that you can do teleoperation and simulation to train, and like that Figure Robotics demo that we showed about operating a Keurig. That was the ability for it to using a bunch of teleoperations, and then it was able to now do it autonomously. And then you've got the large language model that can come in and be used so you can communicate to it and it to be able to understand you in just whatever language you normally would use. It doesn't have to be very specific words that you use at certain areas. It'll know what you're doing. You can talk it. You can talk back to you. And so now it really is just continuing the autonomy and the speed of the bot. How quickly do you think they can improve the speed of the movement of the bot?
That's a good question. And I think right now they're looking at the power consumption and probably trying to make sure that we can go a little bit faster, but it might require too much power. So what do we try to do to make sure we can do both of those things? The other is, and this is something James Downwood kind of pointed out, is that they probably don't want to push it too fast because these bots are kind of expensive and they fall over and break. Then, you're not able to do the research work. So they might be slowly turning up the dial to get them to walk a little bit faster to make sure they're kind of confident that they can go ahead and do it. And again, Brett seemed to be very confident that they'll be able to do that with Figure. So I'm sure that if he's got that confidence, Tesla probably has the same confidence. They've looked at everything, they simulated everything ahead of time. They're pretty confident they should be able to hit those numbers for the walking. I don't think you need to necessarily have to walk at 3 miles per hour to already start to do useful work, because there'll be some operations where it's just a couple of steps here and there, and you're never really going that fast. They might be able to do it. It's more in the movement in the hands. And I think the torso seems to be quick enough for me for many operations that you would need to do. Because again, I keep on stressing, a shift is a marathon. It's not a sprint. And if you're going to be doing, wild things for 8 hours, you're going to be exhausted. So you've got to make sure you're able to pace yourself. The robot will be able to pace itself. And that's why the useful work will be there. And then they will crank up the speed more and more. Now, I did say earlier, it's like, I don't think Boston Dynamics can do it because it's going to run out of juice after like an hour and a half or 2 hours. It needs to go the whole way. And you might be saying, well, what about the other bots? Will they be able to do it? And I showed it, with a series of posts last week, and we covered that as well. The idea of using the shifts themselves in there as an opportunity to top off the bot. So if you're in a factory with human workers, there's already scheduled shifts in there. And the scheduled shifts are like every hour or so. The Tesla bot has more than enough power to go at full drain for about 4.5 hours, which means it could make it the lunch hour quite easily. The thing is, there's always a mid-morning break. So even before then, you can top it off. And it's kind of nice is that at that time, you're in the sweet spot of the charging curve. You just come down enough. In that 15 minutes, you can get a lot in there with just kind of a standard charger to get you back up to a good level that you easily make it to lunch. And you look at it throughout the whole day, the bot has so many margins, it's like easily can make 8 hours. Now, it's gonna be a different story when we have a factory with only bots, in which case you say, that's it. No more lunch shifts, no more mid-morning breaks. You're running, and then you're gonna have to be coming up with something else. But that day is still, way in the future. And by the time we get there, we're gonna have different strategies to be able to keep the bots going for 8, 16, 24 hours without, constantly having to be charged or really quick charging. So confident it will be able to do it, the power won't be the limiting issue. The limiting issue is the durability of the bot, and is there a task that it can do reliably? And I think there are tasks it can do reliably already.
And that's why it matters. We saw this and it's very impressive, but it's actually very big, very bulky. And so how long can it last? Because it's just so heavy. Surprisingly, when you're that heavy, you should actually have bigger batteries. Here's Figure, and you notice that it's got a backpack. And that's probably, I'm guessing, the battery. And it's still pretty, it's still very, very bulky as well, but it's still a lot slimmer than Boston Dynamics. And here you've got Tesla Bot, which seems to have really figured it out. Like they look like they're pretty slim now. And if you're telling me that this Tesla Bot can do 4-hour shift with before batteries die, and it sounds like I'm going to go ahead and assume that Figure also is 4 hours. But unfortunately, Boston Dynamics is just at 2 hours.
Right. If you go to the Figure website, I think they might be estimating around like a 5-hour battery lifetime. So we don't know exactly the size of the battery pack to have in there and everything else. So the Tesla Bot is worst case about 4 hours if it's at full drain. If it's at what would be the average drain, it's able to go 8 hours without having to do anything else. And we're just mentioning that we can get that shift with really heavy margins, just leveraging the fact that you have breaks during the day.
Yeah, breaks,
even at full drain. So you can have an operation that requires the full amount, and you're fine.
Yep, 10-minute breaks every 2 hours, and then a 30-minute break during lunch hour is enough to bring it up and keep working straight out. 3 shifts a day, not even just one shift.
Exactly. You can make it to 3 shifts.
Yeah. So the key thing here is, so in terms of batteries, you feel like that's resolved. It's just moved slowly. And part of that is because the neural nets still need to develop, because this is the bot learning how to walk, learning how to move. And you don't want to have to code it. And that, I think, is the other thing, is that it's still pretty obvious to me that Boston Dynamics is still very much coded. It was coded, meaning, okay, we're going to grab that thing, we're going to put it over here, you're going to walk this way, and every step has been designed. They make it look like it wasn't. I don't believe that they're quite,
I think there were a lot of tasks in which they had probably coded quite a bit, because if they were using something else, they would have said so in the post.
Yeah.
They only said perception. They could have said something like end to end, or some kind of neural nets that we're using, or neural training, but none of that was in there. So I suspect that, yep, they're just using the camera system to identify the part, and they already know what the procedure is for being able to grab this particular part and what we want to go through. So in many ways, it looked like what I would see a normal industrial robot do, as far as being able to identify a part over there, go down there, grab it, get it up there, maybe doing something else to manipulate it. The only difference is that this one's walking on legs rather than a robot with a big arm on a track trying to do the same thing.
Yep. Wonderful. Thank you so much, Scott. That was fun. This is Boston Dynamics. I'm glad that they're making move forward, and it's pretty exciting. I mean, obviously, we want to see more robots out there, and they're all coming out, dropping demos. And so, next demo that comes, we'll be at this again, and we'll see exactly what they're doing. Scott and I just interviewed the Sanctuary CTO, Suzanne Gildert. We're going to drop that video by this weekend, depending on when I drop this video. But it might actually be the same day, actually. So we'll see. But anyways, keep a watch out for that video, because it was very eye-opening. Sanctuaries.
Absolutely. Robot. And there were so many things I wanted to say about that video that I'm embargoed to say until we actually release it. It's definitely worth having a listen. And Suzanne Gildert is like a wonderful interviewee. Yeah. And we hope to be able to interview her again if she'll have us back. And I think she will.
She will. Thank you so much, Scott. That was fun. Bye-bye.